All right, in this video, we're going to talk about the properties of rational exponents. So we already did this in one of our other videos, but just to show you that all the properties that we learned before still hold true, even if we have rational exponents, meaning we have fractions in our exponents. So when we multiply, we would add our powers. When we have a power to a power, we multiply, and we would still distribute that power into both of them, even if it's a fraction. And then if it's raised to a negative power, we would take its reciprocal. So since it's in our numerator, it needs to drop to our denominator. When we divide, we subtract, and even if it's a fraction, we would still distribute the power to both our numerator and our denominator. So we've already talked in detail about these properties. I'll just erase this in case you want to take a screenshot. You don't have anything written, but these are just properties that we've already discussed, we've already used, just showing you that it holds true even when they are fractions. All right, so now we're going to go through one of these problems. So now when you first look at this, you might say, all right, we're dividing radicals, our indexes aren't the same, so there's nothing we can do. So you might say that's our final answer. However, if you look closely, you can see, well, all right, our indexes aren't the same, but our radicands are. And if we were to rewrite both of these as a rational exponent, then we would have the same base, and we can use our powers that we just described or talked about in the slide before. All right, so what you want to do with this then is, even though they don't have the same indexes, we want to rewrite these as a rational exponent. And remember, it's power over index, power over index. So it's x to the 3/4 power divided by x to the 2/8 power. All right, so now that we have the same base, the same number that's being raised to a power, we can go ahead and we can subtract since we're dividing. So we can rewrite this as x to the 3/4 minus 2/8. And 2/8 simplifies to 1/4. So it's x to the 3/4 minus 1/4. This will then give us x to the 2/4 power, which is then equal to x to the 1/2. So it can reduce to 1/2. So our final answer is x to the 1/2. Since it was written originally as a radical, we should write our final answer as a radical. So it's power over index. So this, as our final answer, is going to be the square root of x. So that is your final answer, right? So at times when you're asked to simplify or reduce your radicals, you may want to look and see, well, if I rewrite it as a rational exponent, will my rational exponent simplify? And if it does, you need to simplify that fraction, right? This is your final answer, the square root of x and nothing else. All right, and then another problem that we can use this for is we're multiplying this together. So the square root of 13 and the eighth root of 13. So once again, you might look at this and say, well, this is an index of 2 and an index of 8, can't do anything. But when you look a little bit closer and you see you have the same radicand, you can say, all right, well, if I rewrite this as a rational exponent, my bases are the same, and I can use the properties that we've learned. So this one can be rewritten as 13, and remember, it's power over index. Our power is 1, our index is 2, so it's 13 to the 1/2. And this one could be rewritten, I'll write this one in black. So it can be rewritten as 13. Our power is 1, but now our index is 8, so it's 1/8. All right, so now I know I'm going to have to add 1/2 plus 1/8, so we'll do this off to the side just to refresh your memory. To add fractions, we need to be in equal parts, so we need to have the same denominator. Because if I try to trade you 1/8 of my candy bar for 1/2 your candy bar, you won't do that. So we need to find common denominators. So if we multiply 2 by 4, we'd get 8. And so that way we don't change our value. We need to multiply the whole fraction by 4. So this becomes 4/8 plus 1/8. And 4/8 plus 1/8 is equal to 5/8. When we add our fractions or subtract, our denominators don't change. We just add or subtract our numerators. So then this would be rewritten, our final answer. So when we multiply, it will be 13 to the 5/8 power. All right, now you could leave your answer like this, but since it was first given to you as a radical, you can rewrite it as radical, and it'll be 13 to the 5th power, and it's the 8th root, or you can rewrite it as the 8th root of 13 raised to the 5th power. Now, if you were to rewrite it in this way, you should really keep going, and since we can raise 13 to the 5th power, we could rewrite it as the 8th root of 371,293. All right, and if you write it this way, then you can leave it like that as your answer, since you're saying the 8th root of 13, you'll raise it to the 5th power. but any one of these would pretty much be acceptable. All right, any one of these would be fine. All right, they're all interchangeable. All right, that's it for this video.